Hey everybody, today we're doing confidence intervals in R. This is particularly useful when you have an actual data set as opposed to just summary statistics about a data set. So here I'm going to be looking at the CO2 data set. It's built in with R. I'm going to be interested in the uptake variable. In examples we've done previously, instead of having a full data set, we just had the sample mean x bar and the sample standard deviation s. And we could compute those directly and use previous techniques. Here we're going to see a shortcut. The command that we're going to be using is t.test, and then we feed it the variable. So here it's in the data set CO2, and it's the uptake variable. It's going to default to a 95% level of confidence. It's going to give us a lot of information here that will become more interesting to us when we get into hypothesis testing. Right now, the things that we are most interested in noting are the 95% confidence interval, of course, that it's giving us. It's also giving us a point estimate. This is going to be the sample mean, 27.2131. If we had to estimate the population mean, this would be the single number we would give. Also notice that it's giving us the number of degrees of freedom. That's one less than the sample size, so 83. Things like the p-value and the alternative hypothesis we'll get into when we talk about significance testing in a future video. So one thing to notice is that it does not directly tell us the margin of error. We can compute that. We know that the margin of error is going to be the difference between the uppermost limit, in this case 29 point blah 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 blah, and the sample median, sample mean 27.2131. So the margin of error here is going to be 2.34687. Great. We can also do this confidence interval by hand. Let's do that for practice. Remember the margin of error for a t confidence interval has the form t star s over the square root of n, where s is the sample standard deviation, n is the sample size, and t star is going to be the critical t value for the 95% confidence interval. In other words, from negative t star to positive t star under the distribution t of 83, we should get 95% of the area of the probability. That means that outside of that region is 5%. On each side is 2.5%. So in particular, to the left of t star, we should have 97.5% of the probability. So we can get the t value there with the qt function, 0.975. We need to give it the area to the left of that value. And then we have to feed it the number of degrees of freedom, in this case 83. That's going to be t star. Let's multiply it by the standard deviation of this variable. So uptake. And then divide it by the square root of the sample size. And we get exactly the same number as before. Here R is just doing a slightly different amount of rounding. The last thing we should mention is how to do different confidence levels. So let's go back up to that t.test function. If we want, say, a 90% confidence level, we have to specify an additional argument, conf level equals. And then, of course, we'll give it the percentage, so 90.90. Bear in mind, when you decrease the level of confidence, you should get a more narrow confidence interval. So let's watch the endpoints. In the previous case, when we did a 95% confidence interval, the uppermost limit was 29.55997. We expect a smaller value here. And in fact, we get 29.17585, so it is smaller.